Hey guys, Eddie Komanek back here at the Enjoy Workshop, and I thought I'd just do a quick video on the standard lure coursing machine. We're not really going to get into reversibles this time because in my opinion, this is the machine that 95% of us should be running for bass cats, for lure coursing trials, any big events. A little bit more reliable, and I'll get into the reasons about why you should choose this over reversible in a bit. But let's start out with what our machines are. It's a 12 volt DC series wound motor running at 2.5 horsepower. There are other motors out there. I've seen gear reduction motors. I know there were 6-volt setups. Some people run even a 24-volt setup. I've tried that before. It overheated a little, so 12 volt seems to be a good place to be, especially when it comes to chargers. There are some clubs out there that run gas-powered machines, and I'm not very good at building carburetors or debugging an issue with a gas-powered machine, so I don't use those. I've used 12-volt DC forever. There are also some AC machines out there, and people are having luck with those. Cool, but I think they're kind of limited in the amount of yardage that you can run with those machines and the top speed of them, so I'd be wary about using those. So these motors, the reason we use a 12 volt DC, they were originally like starter motors off tractors, and since then it's pretty much a winch motor package. By the way, I'm going to do this in one take, no cuts, so if I make mistakes, I make mistakes. But anyway, they have a very high torque, a very high speed, and they're not really, their torque is not bogged down by any kind of strain on the motor, so they're very powerful machines. The other nice part about a DC setup versus other setups is that you can run them in tandem. So if you're running over a lot of terrain, you're getting a lot of drag, you're not achieving that top speed, put in a second machine in tandem. And I'll show you how to do that in another video, probably out in the field so I can demonstrate it. But put in a second machines and you won't have any issues. And they're also easily repairable. Basically a few bolts and you can pull the motor off, a couple more bolts and unhook the solenoid. You can swap out a solenoid in the field in about 10 minutes. So that's another really good thing about running a DC system. Other requirements that you need when you run one of these machines is a battery. Now, the type of battery I usually recommend people go to Walmart, get the biggest marine deep discharge battery they can find, 12 volt. Those are usually going to run you about $200 to $250. But if you run them all the way down, they're not going to be damaged by that action. So, and Walmart's usually open 24/7. If you have a problem with the battery, you can take it back to Walmart. So they're very good about that. And those batteries should last you about 5, 6, maybe 7 years if you're lucky, at which point you're going to want to replace them. You're going to need a battery charger to keep those batteries topped up as you're running. I'll get my charger out real quick and show you what I use. So I run an Associated big charger that can output about 60 to 80 amps continuous duty. You can run a smaller charger, but considering we usually run 2 machines at a time with a bank of 4 batteries, I want a big charger. I can run those 4 batteries on that charger and be fine all day. And a power source for the charger. You can run a generator, you can plug in if you're conveniently close to one of those. Worst comes to worst, if your charger fails, you can always put a jumper to a car, and that alternator will keep the batteries topped up. As far as components of the actual machine, let's take a look at the nitty gritty here. So you've got your DC motor right here, and that is the powerhouse. You've also got your solenoid right here. That is this little thing. And all a solenoid is a basically a switch. So there's a plunger in there that when you push the button, it clicks the plunger and then it creates a circuit to the big voltage, big current connection. So 1 amp through the button multiplies to hundreds of amps through the motor. Additionally, we've got, I'll go over the button real quick. So the button is basically just a Omron micro switch. You can hear a little clicky right there. On a cord that plugs into this little receptacle down here. Our machines all come stock standard with a voltmeter on the top, so you can see what voltage your batteries are sitting at. And of course, when you hit the button and there's power going through the machine, it's going to drop that little needle a little bit. And then this machine has the additional click counter right under there, so you can tell how many times the motor or the solenoid was actuated. That's not standard. I really don't use them too much, but some of our clients do like those. I guess after so many clicks, they switch out their solenoids. Let's see, DC counter, and then the fan. That is the last most important thing that you put on one of these motors, because they will build up a lot of heat, and they'll build it up through the core, not just through the outside. So while you're trying to cool the outer shielding casing of the motor, that core is still getting very hot. So it's very important that you ventilate through the core of the motor. So all of our motors are now drilled on the back plate and on the face plate, which you're not going to be able to see here, but there are holes on the motor itself, so that when you hook up one of these fans, you're going to put that over, and there's going to be an inner lining of foam that you want to fit over the back snugly over the motor. And then there's a connection, purple to purple, blue to blue. You hook that up, and then once you're connected to the you flip the switch on the fan and it'll turn it on. This one says master because that's my master fan for reproduction. Operation. So it's pretty simple. Plug in your switch, hook your machine up to a battery. And if you're just running a short practice, you really don't need a charger or anything on it. You could probably just run off the battery. But anyway, you push button and it turns the motor. Very simple, except that when you're pushing that button, you've got about 1 amp going through the coil of the solenoid. That multiplies a lot. So these solenoids are rated for 200 amp continuous duty at 12 volts. That doesn't mean there's not more current going through them. When the motor's at a dead standstill, you get a lot of inrush current. That could be anywhere from 600 to 700 amps. That inrush current quickly drops off once the motor is actually spinning. And once you're clicking the button, it'll keep going at that lower amperage. We've upgraded NJOY from, I think there were 125 or 150 amps maybe, to 200 amp continuous duty solenoids. So these are a little bit more robust. You can find these solenoids elsewhere. It's basically a Hersey solenoid. And there are like 500 amp continuous duty, and I've used those out in the field, and I've not really noticed a massive longevity improvement in switching to those 500 amp solenoids. The 200 amps seem to be doing a great job. And the other big thing with operation is, like I said, keeping the motor cool. That's going to affect not only the performance, the speed of the motor, but also, you'll end up burning out a motor if it gets too hot and you run it for too long. So cooling is a must on these. So let's talk about some of the problems you can have when you're out in the field running these motors. Low voltage is probably one of the biggest issues that I see. If your batteries are old, if they start running down while you're running, your charger's not enough, you'll start building up heat. You'll build up heat in the motor, you'll build up heat in the actual wires. You can, as a test, when you're running, if you're seeing performance issues, walk up and feel all of the different cabling coming off and see if one's hot. It may just be that you need to clean the terminals, tighten down a nut on the connector. So that may be the issue, or I usually recommend people have a voltmeter that they can see what the battery bank is sitting at when nothing's running. And if it's sitting, below 12 volts, you're in trouble. When a charger's on it, you should see about 13.5 volts. If your charger's kicking off and refusing to charge it, or throwing a bad battery warning, then that may be time to change out your batteries. If you're getting a lot of, as a heat test, I usually walk up and feel the casing. If the casing doesn't make me take my hand off it immediately, it's usually okay, but the cooler the better on the motors. Like I said, check your battery connections. Keep those clean. You can buy those little scrubby things to clean out the connections. Wire brush is a good thing to have as well to clean the connections. If they're not AGM batteries, so they're full of water, then you need to check and make sure the water's topped off on those batteries. Yeah, and keep all your connections tight. If you're having a lot of heat buildup, another thing you probably do is put in two machines. If you're noticing, the lure's not running as fast as you'd like it to, it's really bogged down, you're running over a lot of terrain, then it's maybe time to run two machines in tandem. And like I said, when we set up one of the fields this weekend, I'm going to try to take some video out there of what a tandem setup looks like, how it's hooked up. Let's see, what other issues can you have? If the charger's kicking off. Usually if the charger's kicking off, that's usually a heat issue in the charger itself. Like it's saying, I'm getting too hot, I need to cool down for a minute. Try putting a fan on the charger if it has vent holes on it. If you can't do that, you may think about putting a second charger in there to kind of pick up the slack. With my big guy, if he is in direct sunlight, sometimes he'll kick off, but if I put a tent over him, that usually helps a lot. And sometimes I'll strap a fan to the side of it just to help with the heat within the charger. So the other issue, usually points of failure, is going to be the solenoid. So running such high current through these solenoids will actually make the plunger contacts stick and stay stuck. So if you're pushing the button and all of a sudden it runs away and you've come off the button, that's usually a stuck solenoid. You can immediately stop that by usually taking a hammer and tapping on the solenoid, and that will unstick it. But do not run on that solenoid anymore. Get a replacement, swap it out, switch out to a different machine, something, but that solenoid has to be replaced. If you're running and you're hitting the button and it's clicking and nothing's happened, first, check your connections. Second, see what the voltage is across the motor and see if it's pulling any current and just not turning. That might be a burnt out motor. Recently, I had a button fail for the first time in my lure coursing career, and basically that fails just like a stuck solenoid. It'll stop doing the clicky click, and it was squishy. But when I hit that, it was just like a stuck solenoid. I ended up swapping out one or two solenoids before I figured out my button was failing. It's always a good idea to keep spare parts whenever you're running an event. Keep a spare motor, keep a spare solenoid or two, keep a spare button. That just makes sure everything goes smoothly. I guess that's about it. If you guys have any further questions, feel free to leave them in the comments, but this is just a quick primer on what the DC setup is and why we run this. It's so much easier, in my opinion, dealing with any kind of issues that come up in the field and you need to fix them within the next 10 to 15 minutes. So leave your questions in the comments and I'll get back to them. Thank you.